Okay, the next type of energy is also related to what we just talked about. So remember, work and energy. So the term work means that we're applying or transferring a certain type or amount of energy in order to move something. And kinetic energy is anytime you see the word kinetic, this is the key word that kinetic means. And you'll see it in various places. But if you see the word kinetic, it means something's moving. Okay, so kinetic energy is basically energy possessed by an object due to its motion. So remember the example we just looked at with gravitational potential energy. If we take any object that has mass and we lift it above the Earth's surface, we're giving it gravitational potential energy. And the word potential just means that it's stored. It's not being used yet. So potential just means that there's some energy there that can be used. And if we're giving it gravitational potential energy, that stored energy is in the form of transfer of gravity. Gravity's going to, if we let it go, it's going to pull it back down towards the Earth's surface, and it's going to convert that gravitational potential energy into energy of motion, right? Because it's going to start moving. And so when we bring something above the Earth's surface, it has gravitational potential energy. When we let it go and it begins to fall back down, we're giving it kinetic energy. It's changing its all the gravitational potential energy it had, and it's being converted back into kinetic energy. And so work is being done when this sort of thing happens, if we're transferring energy. So that's how work and energy are related. How we calculate kinetic energy is a little bit more involved. So our formula for calculating gravitational potential energy looks like this. So again, a capital E for energy, and kinetic, we just give it a lowercase k. It's equal to mass times velocity squared, all divided by 2. Okay, and so kinetic energy, remember energy is always measured in joules, the mass is always measured in kilograms, and velocity, this goes back to our very first unit, is always measured in meters per second. So you've seen that before as well. Let's look at a couple examples of how to solve using an equation like this. Okay, first one. The kinetic energy of a 6 kilogram bowling ball rolling at 5 meters per second. So again, start by writing information that you do know, and then you're going to be pointed in the right direction of what formula you're going to use and how to solve it. So we have a mass of a bowling ball, which is 6 kilograms. It's rolling, so it has a velocity of 5 meters per second. And what they want us to find is the kinetic energy. So we start with now, the other thing, remember I said if we have 3 variables, we can use this magic triangle. Well, the reason we can't use this magic triangle here as well is because this velocity is squared. And so it's not just a simple 3 variable multiplication and division type thing that can be put into the magic triangle. We can't use the magic triangle here either because of this squared symbol. And so remember that in case you forget that the squared symbol, so v squared, is the same thing as saying v times itself. Okay, from the law of exponents. So let's substitute our numbers in and see what we end up with. We end up with 6 times our velocity, which is 5. But this velocity gets squared. So keep in mind that this too only applies to your velocity value. Okay, it does not apply to this. And if you remember our order of operations, you want to solve. So remember order of operations, say brackets, solve brackets first, then exponents, division, multiplication, addition, and subtraction. So you have to solve this squared sign first before you can do anything. So, and it's all divided by 2. So first thing you want to do, and I'll show you in steps. 5 squared is the same as 5 times 5, which is 25, all divided by 2. Now that your exponent is simplified, it doesn't really matter the order because all you have left is multiplication and division, which they can be done next, and that doesn't matter what order you do them in. So 6 times 25 equals 150. So I simplified the top first, divided by 2, and we end up with 75. And it's joules because we're solving for kinetic energy, and we end up with 75 joules of kinetic energy. Okay, I think I have one more example, yes. This one's a little bit trickier because now we're going to solve for velocity. So what would the velocity be, this should be B, of a 17 kilogram bale of hay if it had a kinetic energy of 212 joules? So our kinetic energy is 212 joules. It has a mass of 17 kilograms. And what we're trying to find is velocity. Now this one gets a little tricky because remember in our formula, and I'll put the formula down, mv squared divided by 2. Our velocity is squared, so if we're solving for velocity, we're going to have this extra step in here that has to tell us that we got to get rid of this squared sign. So let's put our numbers in and see what that looks like. So we have 212 joules of kinetic energy equal to this mass, so 17 times v squared, all divided by 2. Okay, so remember I said anytime you have numbers on one side of the equation that you can simplify first, do that. This is 17 over 2, so we can divide this out. 17 divided by 2. We end up with 8.5, so we end up with 212 is equal to 8.5 v squared. And remember I said anytime you have two variables that are multiplied, so 8.5 beside the v squared is the same as saying 8.5 times v squared. And in order to get rid of a number that's on the same side of the equation as the variable that we're trying to solve for, you do the opposite operation. So if it's being multiplied, we have to get rid of this 8.5 by dividing it. And whatever you do to one side of the equation, you also do to the other. So divided by 8.5, remember, just equals 1. Anything divided by itself equals 1, but over here we end up with figuring out 212 divided by 8.5. So 212 divided by 8.5 is equal to 24.94, and that is equal to 1 times v squared, which is the same as just saying v squared. Now, we're trying to solve for velocity, so you might think at this point we're done because we have this v on one side of the equal sign by itself. But the extra thing here is that it's v squared, and we're not trying to find out what v squared is. We want to know what just v is. And so here you have to do an extra step. Remember that v squared is the same as saying v times v. The opposite of the squared symbol is the square root symbol. So if we take the square root of v squared, basically these two things cancel each other out and you're left with v, which is exactly what we do. If we want to get rid of this squared symbol, we have to square root it. Whatever you do to one side of the equation, you also have to do to the other. So that gives us the v that we want, and on here we just have to figure out what that answer is. We end up with 4.9. So we can say that our velocity is equal to 5 meters per second. Okay? That's as tricky as it gets. So if you have an example that's just like this when you're solving for velocity, you can follow the work that I've done here. Okay, and the final example we're going to look at is basically just another term that combines both your gravitational potential energy and your kinetic energy. And this term is called mechanical energy. Mechanical energy is the sum of these two types of energy. And I'm going to give you an example that you can relate to. The most common example that physics textbooks use in this case is roller coasters. Mechanical energy, which is the sum of these two energies, helps to explain why roller coasters work. So if we think of a roller coaster, always starts off with a nice big hill. And then we end up coming down. Okay, we have to pull the cart up that first initial hill. So energy and work have to be done on the cart to get it up here. But let's just say we're at the top here. And let's say up here, we've calculated based on the height above the ground that we are, that our gravitational potential energy is at 100 joules. Let's say 98, because it's still moving a little bit. And our kinetic energy is at 2 joules. What mechanical energy says is that whatever you start with for both of these energies, it stays the same. The sum of them stays the same the entire way through. Let's say there's another hill here. And so if you start with a total of 100 joules of energy, Most of it's gravitational because of your height above the Earth's surface. And at this stage of the ride, you're moving slowly, so you have a little bit of kinetic energy. What mechanical energy, and this is what the conservation of energy says. Conservation just means that the total amount of energy is not changing. Okay, the total amount of energy that you start with is going to be constant throughout. So let's just say this cart now starts to move down the hill. And let's say we're about halfway. What happens is the total still stays the same. And this is what the conservation of energy says. The total amount of energy you start with is still the total amount of energy you have at any one point in your trip. But what happens is halfway down, you're moving pretty fast. So around here, all of the gravitational potential energy that you had is being transferred or converted into kinetic energy. And so what that looks like, let's just say we have about 50-50. If we have 50 joules of kinetic energy now halfway down the hill, and we had a total of 100 to start, it means that there's 50 over here. Okay, so conservation of mechanical energy means that it stays constant, that you're always going to have 100 at every single point in your trip. Now let's just say what we are down here. We're maybe, let's say, a couple meters above the Earth's surface when we're at the bottom dip of our roller coaster. What the conservation of energy states is that no matter where you are, you're going to have the same amount of energy you started with. So the sum of them should equal 100 always. That's what the conservation of mechanical energy says. So that means that if at the bottom of our dip, because we're pretty close to the Earth's surface now, we barely have any gravitational potential energy. Let's say we have 2 joules. That must mean that the remainder of the energy, which is kinetic, must be 98 in order to add up to the 100. Okay, so conservation of mechanical energy just says that whatever amount of energy you start with is constant throughout, but it can be transferred from one form of energy to another. And the word mechanical energy means these two forms here, gravitational and kinetic.